Today's video, we're going to look at how we can find the tension force. In particular, we're going to start with how to find the tension force in single block systems, one mass, and the simplest of this kind of system is one mass, one block with a single rope. So let's draw our diagram. We have a block, mass 1 of 2 kilograms sitting on a horizontal surface, and now there's a rope that's pulling it to the right, and there's some tension, some force T that exists inside that rope, and it's being pulled at 60 degrees from the horizontal. Great. We also know that this block is experiencing an acceleration in the right-hand direction of 3 meters per second per second. This is the information we're given. Now, what is the tension force that we're looking for? The tension force is the name that we give for a force that exists or exerts its force through an axis of some sort of material. Typically, we say a rope or a chain could be an example of these kinds of materials, and we give this force a name, we call it tension. We give other forces names like the normal force, which exerts itself upwards or in an opposite direction from the gravitational force. So tension force is what we're looking for right now. So how do we find this tension force? So right now we know that this force is moving in the rightward direction. Great. So let's redraw this diagram here into a little triangle here. And we have T, which is going in the top right diagonal direction. There's some angle 60 degrees. I know this triangle isn't drawn correctly, but nevertheless, we will continue. And now this T is going at an angle. So therefore, there must be some component of this force that's being used to pull the block to the right in the horizontal direction. So we call this the X component. And similarly, there must be some component of this force, some portion of that force that is being used to pull the block upwards, maybe a certain amount. And we call this the Y component of this force. So these two components together make up the tension force that we're looking for. Now, we are given the acceleration in the X direction. So we already have this, 3 meters per second is the acceleration that it's experiencing. So now we can use Newton's laws, Newton's second law, F equals ma, for the horizontal direction. So we'll say F of x. We know what m is, it's 2 kilograms, and we know what the acceleration is, which is 3. So together we get 6 newtons of force going to the right. Right there. Good. Now, let's redraw this triangle now. Let me redraw it correctly this time. T, Ty, and now Tx equals 6 newtons. Now we're going to pull out our trigonometry, which is nice. So now to find T, we know one of the side values. We know what one of the angles is. So now we can find what T is. So in this case, we're going to do T equals T of x over cosine of 60, because this is the adjacent side and this is the hypotenuse. So substituting in everything that we know, 60 or 6 newtons over cosine of 60 gives us 6 over 0.5 equals 12 newtons. So we know now that T, the tension force here, is equal to 12 newtons going up that way. Now, if you wanted to find what the Y component was as well, you could do that, and that would just be another example of a trigonometry problem. And this time we will use sine 30 instead of cosine. Cosine of 60. Because that's the angle that we know. Now let's move on to a slightly more complicated system. Now we have the same single block, but instead of one rope, we have 2 ropes. Let's say we have a room, and we have a box that's being suspended from the ceiling by 2 ropes. there exists some force T1 in the first rope, and there exists some force T2 exerting along the second rope. We also know that this block has 2 kilograms of mass, and that the rope makes an angle of 30 degrees from the horizontal. Great. What else do we know? We also know that this block experiences the force of gravity. That pen is very large. We know that this block experiences force of gravity, which is, of course, mg. Good. So how do we find T1 and T2? The key point in this is that this block is stationary, it's not moving, which means the net force that this block experiences must equal to 0. In particular, the components of the force in the x component and the y component, in other words, the horizontal and the vertical forces, must be equal. So, what are the vertical forces that are happening here? We have a vertical force over here from T2, we call it the y component, and then we have a force due to gravity opposing that. Horizontally, we have the x component of T2, and we have T1 going to the left. Technically, it would be T1's x component as well, but because it's perfectly horizontal, that is the only direction that that force is being exerted upon. Good. So now we can write the relationship down. We have T2 of y, which is that vertical component, equals the component that is opposing that, which is weight, so the force due to gravity. To make this a little bit clearer, let's draw a triangle. 30 degrees. This is force T2, and T2 has a vertical component and a horizontal component. So we're looking right now at the vertical component. The vertical component is moving upwards, and the only force that's opposing that right now is the force due to gravity. And this equals mg, of course, the force due to gravity. And also, if we look at the triangle, we have another relationship for what T2y is. T2y, if we use trigonometry in that triangle, is equal to T2 sine of 30, because it's the opposite side over the hypotenuse. So we have sine of 30. Gives you the relationship between T2 and T2y. So now we have two equations. How convenient. So we know what m and g is for this first equation. So let's just substitute that in for us. So T2y equals mg. We can substitute in 2 kilograms, and let's say the force due to gravity is 10. So we have 20 newtons here. Excellent. Similarly, we can substitute this into the second equation that we have here. So substituting that in, T2y is equal to 20 newtons, which is equal to 2T2 sine of 30. So we can rearrange to find T2, which of course is 20 over sine 30, and we have 40 newtons in total. Great. So we now know that T2 over here is 40 newtons, moving in the diagonal direction to the top right. So that's T2 sorted. Let's look at T1. T1 is the horizontal component that we're looking at now. So we know it's not moving, so therefore T1 must equal T2x, because these are forces in opposite directions. They must be equal for this block to not be moving. T2x, if we look at this triangle again, is T2 cosine of 30. Last time we used sine of 30 for the y component. Now for the x component, we're looking at the cosine. And if we substitute in all the values that we know now, we know what T2 is. T2 is 40 newtons. Multiplied by cosine of 30. Now, if you know your trigonomic identities, then you'll know that this is 40 multiplied by root 3 over 2. If you don't know it, I highly recommend you remember them, memorize them. They're very convenient, and it makes the math very neat. Because now we can simplify to 20 root 3. The 40 and the 2 can be simplified. And if you want that as a decimal, it's 34.64 newtons. So, unfortunately, the numbers are not particularly clean, but you get the idea that we can find the components of any force that is not acting perfectly vertically or perfectly horizontally. We can break it down into the x and y components and then equate them to find the total force that is acting upon that rope or through that rope. So let's move on and find something a little bit trickier. Now we have the same system, same block, but now instead of being tied by a horizontal rope, it is now being tied by two vertical ropes or diagonal ropes. Let's say it is the same. You know what? Let's change it to a 5 kilogram block, just so the maths changes. And now we have rope T2 making a 60 degree to the horizontal, and we have rope T1 making a 30 degree from the horizontal. Excellent. So, like I said, if the ropes are not perfectly vertical or horizontal, we can break it down into its component forces. So let's do that. For the left-hand side, T1, let's break it down into its component Ty and Tx, or T1x, T1y. And what are the two equations we can write here? Using our trigonometry, we have T1 of y is equal to T1 sine 30, and T1x, the x component, is equal to the T1 cosine of 30, because T1x is adjacent to that angle, and T1y is opposite 30. Good. So these are the two equations we can draw for the left-hand side. Let's draw the right-hand side. The right-hand triangle here has a 60 degree. We have T2, and of course the components in the vertical and the horizontal direction. Putting that into equations, we have T2y equals T2 sine 60, and we have T2x is T2 cosine of 60. So now we have these two beautiful equations. So let's start with T1. T1 of x is pulling in the left direction, in this direction here. And T2 of x is pulling in the right-hand direction. So they're pulling in opposite directions. This block is not moving, so therefore we know that T1 of x must equal T2 of x, because the net force must equal 0. So we've written this equation. They must be equal. Let's substitute in the rest of this equation. So T1 of x we know is equal to T1 cosine 30, and T2 of x we know is equal to T2 cosine of 60. Now, I do recommend that you leave these not as decimals. So let's rearrange to find what T1 is so that we can substitute into any other equation later. So T1, if we move the cosine 30 to the other side, is equal to T2 cosine 60 divided by cosine of 30. Now, if you know your trigonomic identities, you'll know that this simplifies down to root 3 over 3 multiplied by T2. If you don't, use a calculator, and if your calculator can give you perfect answers like that, then it will give you root 3 over 3. Great. So that's as far as we can go right now for T1. Let's move on to T2. Now we know T2 is the vertical forces, and both of these vertical forces are pulling upwards. What is the force that's pulling downwards? The only force that's pulling downwards on this block is the force due to gravity. So therefore we know that the sum of all the forces that is pulling upwards, in this case is T1 of the y component and T2's y component, these two forces must equal the force that's pulling downwards, which is the force due to gravity. Great. Let us now substitute in the rest of the equations. We know that T1y is equal to the T1 sine 30. T2y is equal to T2 sine 60. And of course, the force due to gravity is simply mg. We know what mg is. This is just 5 kilograms. Remember, the block is 5 kilograms in mass. Multiplied by, let's say, 10, just to keep the numbers neat. We know this equals 50 newtons of force. So we know that the total force that's going upwards must equal the total force going downwards. So the left-hand side must also equal 50 newtons. Good. Now we have two equations, two unknowns. We have equation 1 and we have equation 2. Let's substitute equation 1 into equation 2. So 1 into 2, we have root 3 over 3 T2 sine 30. So we've put T1 here. We put T1 into here. Carrying on, T2 remains the same. Sine 60 equals 50 newtons. And now you can quickly do some arithmetic. T2 is the same in both, so we can add these two together. So it's T2, this simplifies to 2 root 3 over 3. If you were to use a calculator, you could simply add root 3 over 3 times sine 30 plus sine 60. That will give you 2 root 3 over 3. And again, equals 50 newtons. Simplify this a little bit more. T2 equals 50 divided by 2 root 3 over 3. Use a calculator. That gives you a beautiful 25 root 3. If you want that as a decimal, that's 43.3 newtons. Again, use a calculator. If you want to use decimals, you can. This gives you a more precise answer, and sometimes things cancel beautifully. I do recommend that you get comfortable using this value as opposed to reducing everything to decimals. So now we have this equation, or rather this value, T2 equals 43.3. So we can put this back into 1. 3 into equation 1, which of course is up here. And so let's substitute that in. T1 equals root 3 over 3 multiplied. I'm going to use this value here, and you'll see why in a second, because then I won't have to use a calculator. So this simplifies beautifully. We don't have to do any arithmetic at all. The square roots cancel, the 3's cancel. So now we just have 25 newtons. Sorry, the 3's cancel. So the 2 root 3's multiplied together equals 3. 3 over 3 is 1. So we have 25 newtons in total. If you're confused, let me do that again. Root 3 times root 3 is equal to, what is it? 3. And then we also have a 3 over here. So we have 3 over 3, which equals 1. Great. So that simplifies beautifully to 25 newtons. Great. Now you'll see, now using this method, you could have gone through this entire question without using your calculator once, if all you're doing is carrying over your square roots and your 3's. Good. So let's move on now to something a little bit more difficult now. Let's do 2 pulleys, 1 pulley and 2 blocks, and that will be in the next video.